Okay, so today we start talking about the real number system. And the real number system is broken down into a few different categories, so let's just go ahead and define what those categories are. So first off, each number system category has an abbreviation that we use, and it may be a little different than what you would think. So I want to make sure that we go over that as well as talk about what numbers are included in that category. So first off, real numbers. We use a capital R to represent it, and these are all numbers that you can possibly think of. If you can dream it up, it's a real number. These are going to be your decimals, fractions, square roots, anything that you can think of is going to be a real number. Okay, then we have irrational numbers. So we use a capital I to abbreviate irrational numbers. These are decimal numbers, where the decimal does not repeat or end. So these numbers will continue indefinitely, meaning forever, without a pattern. These are numbers like pi. Okay, continues on forever, doesn't have a pattern. If you do the square root of 2, okay, the square root of any number that's not a square, perfect square, is going to give you an indefinite repeating decimal without a pattern. There's also the negative square root of a number that's not a square, is also going to be an irrational number. Okay. Then we have rational numbers. We've already used R as our letter, so in this case Q is the abbreviation for rational numbers. These are going to be the opposite of the irrational numbers. These are going to be our decimal numbers that either end or repeat. So think about 1/3. That is a decimal that continues on forever and repeats, just a 3. So that would be repeating decimal. Negative 0.75. Okay, that's a decimal that ends at 7.5. And the square root of 16 simplifies to the number 4. 4 has a decimal that ends, 4.0. So that also falls into that rational number category. Integers is the next one. We've already used a capital I as well, so our abbreviation here is a capital Z. Okay, Z is in zebra. Make sure that you got that down. These are going to be whole numbers and their opposites. And that includes 0 as well. So these are going to be -2, -1, 0, 1, 2, and so on. Okay. Then we move into the category of whole number, which we use the words whole number a lot to describe things, but truthfully a whole number is only going to be a complete number. So no decimals or fractions. Starting with 0 and going up. Okay, so this is going to be 0, 1, 2, 3, and so on. Okay. True whole numbers are only going to start with 0. We're not going to include any negative numbers. And then the final one is natural number. We use a capital N for its abbreviation. And these are also complete numbers. So again, no decimals or fractions. Starting from 1 and going up. So these are what we consider our counting numbers. If you start counting about something, you don't usually count with 0, you usually start with 1. So this is going to be our natural numbers, 1, 2, 3, and so on. So these are our counting numbers, and I'm just going to kind of put that out here. A lot of times you'll hear them called that. Okay, so 1, 2, 3, 4, 5. Okay. A couple of main ideas that I want to make sure I point out. This is the real number system, and it is a way that we organize our numbers into categories. All irrational numbers are considered real numbers, but they don't fall into any other categories. And then all other categories of numbers are related, and I'll show that to you in the attached diagram. So if you look, here's what I'm talking about when I say that numbers are related. So there's a couple of different diagrams that we use to represent the real number system. They mean the same thing, but some people visually need to see it in a different way, so I offer both of those to you. So first off, real numbers are all encompassing. If it's a number, it falls into the real number category. And then that is broken into two separate categories. You have irrational numbers and you have rational numbers. So what we just talked about was the irrational numbers are still real numbers, but they don't have any subcategories. It stops at irrational. Whereas rational numbers have further categories and ways that we can relate numbers to them. So all rational numbers are real numbers, okay? But then rational numbers can also be broken down into integers, and then whole numbers, and natural numbers. So you can see how those are all lined up. The representation that I like the most is this one right here, because it really shows how they're all encompassing. The circles really help visualize it for me. So any natural number that you can think of is also a whole number, which is also an integer, which is also a rational number, and it still falls into the big box of the real numbers. Irrational numbers only fall into the real numbers. There's nothing else in those categories. If I'm looking at an integer is a rational number and a real number, but it's not necessarily a whole number or a rational number, or a natural number, sorry. So this kind of helps visualize what we're looking at when we discuss each of these terms. So hopefully one of those two will kind of help clarify the representation of what these categories look like and how we break those numbers down into those categories.